Welcome to lesson 45. The next 2-3 lessons are going to basically be everything you wanted to know about exponents and even more. Today, for example, we will look at negative exponents. Okay, so the first thing we should do, of course, is just make sure we review and understand all the usual rules of exponents. Like first, how about just the definition? What does it mean when you put a 2 with a little 3 up there, right? Well, the 3 is telling you to make 3 copies and multiply, basically. Make 3 copies and multiply. So 2 times 2 times 2, if you work that out, you get 8, okay? I've seen people write 6, but that usually tells me they're in way too much of a hurry, right? If we meant 2 times 3, we would have written 2 times 3. That's not what that means. That means 2 to the 3rd power. 2 times 2 times 2 is 8. Okay, here's one that might trick you. What do you think? What is that? Now you might be thinking negative 2 times negative 2 is positive 4. And if you're thinking that, that's okay. But if you're thinking this is positive 4, no, that's not positive 4, that's negative 4. That is negative 4. Come on, pencil. Negative 4. That one's 8, that one's negative 4. It's negative 4 because we are not squaring the negative 2. We are squaring the 2. And then it's negative at the end, okay? We are squaring the 2. This is a negative 2 times 2, if you write that out. You make 2 copies of the 2, not the negative, just the 2. The exponent is on 2. So it looks exactly like that, and so you actually get negative 4. If you had meant to square a negative 2, you would have to put it in parentheses like this. That way you're making 2 copies of a negative 2. Get it? That would be positive 4. That works okay. But again, that's not what that is. So please be careful about that. It usually surprises an awful lot of people with this. That is a negative 4. Okay, what's this one? 3/4 cubed. Well, literally it means make 3 copies of the 3/4 and multiply them all out. And so the net effect is you've got 3 times 3 times 3 on the top, that's 27. 4 times 4 times 4 on the bottom, that's 64. So that's 27/64. Here's a situation, this one, where this idea of make 2 copies and multiply, you really want to adhere to that strictly. This is make 2 copies of the parentheses. The exponent is on the entire parentheses, so you make 2 copies of the parentheses. And now you multiply those parentheses, and you say, oh, well, I guess I got a FOIL here. So x times x is like an x squared, and then you get a minus 2x, and then you get a minus 2x again, and then you get a plus 4. So this thing, when you expand it out to a polynomial in standard form, you end up with that, okay? This one's even chunkier. You want to try that one yourself, maybe? Get a good, get some multiplication practice going. First of all, you would have to make 3 copies of the x minus 2, and then you would have to multiply them all together. What do you get? Well, you can multiply in any order, right? I could multiply this parentheses times this parentheses, get the answer times this parentheses. I can do that if I want, or if I want, and I do, I'm going to multiply this parentheses times this parentheses, get the answer, and then times this parentheses, because it doesn't matter what order you multiply in, right? I mean, think about how multiplication works. 2 times 3 times 4. What is that? You could say 6 times 4 is 24. Yep, you really could. You could also say, you could also say 3 times 4 is 12, and then you double it, and just 24. You get 24 either way, so yeah, it doesn't matter what order you multiply. It really doesn't. So I'm leaving this x minus 2 here for now. And then I do the old, well, we already see what you get. You get this when you FOIL those things out, right? So x squared minus 4x plus 4. I'll just use my previous result. And then we got lots of multiplying to do here. X times x is x cubed. And then I got a minus 4x squared. And then I got a plus 4x here. Okay, now I got a negative 2x squared. And then I got a plus 8x. And then I got a minus 8. So if you combine like terms together, you've got an x cubed. You've got a minus 4 and a minus 2. That makes a minus 6x squared. You've got a plus 4 and a plus 8. That makes a plus 12x. And then a lone minus 8 at the end. There's what you get. So the x minus 2 quantity cubed is how I would, x minus 2 quantity cubed is how I would read that. And it comes out to, well, comes out to all of this. Notice what it does not come out to. It does not come out to x cubed minus 8. You can't distribute an exponent. I mean, here's examples of, you know what distributing looks like. If I had the 3 in front, that says multiply 3 times this and this. That's distributing. That works. You don't distribute with exponents. Exponents don't work that way. Exponents are make 3 copies. That's how they're defined. Make 3 copies. So I made 3 copies, and then I had to multiply all 3 copies together. So please remember this about exponents. That is your exponent. Well, that is your basic exponent basics. Here's some more exponent basics. The 3 big laws that I know you've seen before. Switch colors. So in this case, okay, you're familiar enough. You know that you're either supposed to multiply or add the exponents, right? So the question is which? Well, here you add, and here you multiply. Okay. Now how do I know this? I know this because x squared literally means make 2 copies of the x times, and those are multiplied. And x cubed says make 3 copies of the x and multiply. So now what have I got? I've got 5 copies of the x, all multiplied. So you add exponents in this situation. Add your exponents. This situation, you're going to multiply your exponents. You're going to say 2 times 3 to get 6, x to the 6th. And I'll prove that to you. You're going to say x squared, which is xx. But you're going to make 3 copies of that. So that's 1 copy. That's 2 copies. That's 3 copies. I got 6 x's there. Or I shouldn't say 6x. I'm not saying this. But, I've got x times x times x times x times x times x. I really got x to the 6th, just like that. Okay, so usually people know these rules. It's just sometimes they kind of get them backwards. Okay, so don't get that backwards. Okay, if you kind of think of it this way, it helps you remember the rule. Okay, and then this one. Now this one, I usually think in terms of canceling. You've got x to the 3 means 3 copies of x, and x to the 2 means 2 copies of x, and then you can cancel, and you end up with just x. That's a natural way to think about it. There's an official rule that says subtract your exponents. That's the official rule. So in other words, I'm saying 3 minus 2. So I'm getting x to the 1 power. I shouldn't. That's not really an equation. Maybe I'll put a colon here. So it's 3 minus 2. And so you get x to the 1 power, which is, of course, what I got up here, x to the 1 power. Okay. So that's the old subtract exponents. Now, this rule here is fun to play with a little bit. So let's play with it a little bit. So the first thing I'm going to do is I'm going to dig on a 0 exponent. Let's go back to blue. So using the rule of subtracting exponents, what would this be? This would be, you'd take 5 and subtract 5 and you'd get 0. You get x to the 0. But wait a second though, if I did it by my canceling way, I'd say, oh, you got basically 5 copies of x all multiplied, 5 copies of x all multiplied. Wouldn't that all just kind of reduce to 1? So what we've just kind of discovered here is that if you have x to the 0, it equals 1. And in fact, I can't say anything, but pretty much anything to the 0 equals 1. Let's say I had 2 to the 5th over 2 to the 5th, right? That would also be 1. So in other words, 2 to the 0 must be 1 because, yeah. Works for everything. So here we go. More 0 exponents. 18 to the 0, it's 1. Okay? That's the idea. Now I got to warn you about a couple things. First of all, 0 to the 0 is not 1. It's undefined. Because the problem is if you have like a bunch of zeros over a bunch of zeros, it's anything with zeros on the bottom is undefined. So 0 to the 0 is undefined. So with that exception, we can say anything to the 0 is 1. You see this big bunch of stuff? That's a whole big bunch of stuff. Yep. But it's got a 0 exponent, so it equals 1. Woohoo! Although if I wanted to be careful, and we probably should, remember, 0 to the 0 is not. 0 to the 0 is undefined. So we have to say so long as x does not equal 0 and y does not equal 0, right? See, the problem with the x's and the y's is they're variables. We don't know what they equal. They could, theoretically, they could equal anything they want. Well, they can't equal 0. If they equal 0, I'm raising 0 to the 0, and that's undefined. So I'm saying it equals 1, and then I'm putting this here as a caveat, so long as x and y do not equal 0. If they do, it's undefined. If either x equals 0 or y equals 0, then this thing is actually undefined. Back to this one now. So this one's, well, 18 to the 0 is 1. Yes, it is. Yes, it is. And if I rose negative 18 to the 0 power, I'd get 1. Is that what this is, though? This is not. This is not this. Negative 18 in parentheses to the 0 power would be 1, but that's not what this is. So think back up here where we were playing around with this one, and we said, no. The exponent's on the 2, not on the negative. Not on the negative. Same thing here. The exponent is on the 0. Excuse me, the 0 exponent is on the 18. It's not on the negative. So this is actually a negative 1. Okay. So just be careful out there when you're wielding your exponents, particularly your negatives in front and particularly your 0 exponents. Okay. Now, I kind of left this over here, but let's dig on our negative exponents next. Negative exponents. So back to that idea of when you subtract. Come on, let's go to a different color. Let's go to a different color and set this apart. You know that if you subtracted exponents, 5 minus 6 is negative 1, right? So in other words, this is x to the negative 1 power. But let's look at it again with this cancel idea. So x to the 5 means make 5 copies of x, all multiplied. X to the 6th means make 6 copies of x, all multiplied. And we get a ton of canceling, of course. And we end up with a 1. Remember, you always leave a 1 behind. A 1 over x. And so we've just discovered this. What does x to the minus 1 actually mean? It means 1 over x. So the negative indicates what? Notice it did not make this into a negative quantity. This is not negative. Okay? Having a negative exponent does not make the number negative. What it indicates is reciprocal. It flipped it over. It used to be an x, but when I raised it to the minus 1 power, it becomes a 1 over x. Okay? The negative indicates a reciprocal. And now, if you look at the next page here, it says, get used to this. The negative on a negative exponent means only one thing. What is that one thing? That one thing is reciprocal. Only reciprocal. Come on, eraser. Erase something, will you? Okay. And it means, let's write this here. It means reciprocal. Only reciprocal. That's all you do is reciprocal. So, we're going to get used to that by looking at a whole bunch of examples here. X to the minus 2, what do you do? Well, it's kind of like a two-part exponent. It's squared. This is an x squared, but what the negative is telling you to flip it over like this, see? 1 over x squared. So that's what the negative did. It moved the x down to the denominator is how I think about it. It moves it. I'm going to move my x. Anyway, something like that. So here, I've got x to the minus 3. Now, if you want, here's the long way. If you want, you say, well, I got 1 over. And then the x to the minus 3 is an x cubed, but it's also, we got a reciprocal going on. So it is still an x cubed. 3 is part of the thing here. It's x cubed, but it's x to the minus 3 means flip that thing over. So you're looking at that, 1 over x cubed. But that's hideous. Please don't leave answers that look like that. Hideous. So you have to remember how you unstack a fraction that looks way too tall, right? So here's my main fraction bar. This is my division symbol, is what that is. So I've got a 1 on top, and I'm dividing by the 1 over x cubed. Now you remember how you divide by fractions? You multiply by the reciprocal. And so in the end we get x cubed over 1, which is just x cubed. We get x cubed. That whole thing is just x cubed. Now come back and look at this. Instant replay, right? It was a negative exponent. Now I said reciprocal, but remember the other way I said it was move it, move it, move it over the fraction bar. If you take that x to the minus 3 and you just think in terms of moving over the fraction bar, maybe I'll use another color now, huh? Purple looks cool. It means move me over. I'm unhappy where I am. I'm a negative exponent. I'm negative. I'm an exponent that's feeling negative. I want to move. I want to move to the top. So 1 over x to the minus 3, really you can think of just move the x to the 3 up to the top. And of course that's the same as x cubed. Just move it over the fraction line. You're going to see me take that shortcut all the time. So a negative exponent means I want to be on the other side of the fraction bar. That's basically what it means. Okay, it's just a different way of saying reciprocal, right? Move me over the fraction bar. Maybe I'll write that down here. Move me over a fraction bar. Come on. I'm negative. I want to move. Move me over the fraction bar. Okay, so that's a particularly useful interpretation when you look at something like that. It's like, you know, do you really want to put all those fractions in there, fractions inside the fraction? No. Let's not do that. A is to the negative 2. Unhappy. Go down. See? Just move over. Now b cubed is happy. Leave it where it is. What about the c? C to the 4th is happy. Leave it where it is. What about the d? D is to a negative exponent. Unhappy. Wants to move. Goes up there. And there's your answer. Just move it over the fraction bar. All right. A few more examples here. What do we do with this thing? 1/5 to the minus 2. Well, again, I'm squaring. That's what the 2 means. And I'm reciprocaling. Reciprocaling? I don't know if I want to say reciprocating. I think that has a different meaning. Reciprocaling. I don't know. Anyway, the reciprocal of 1/5 is 5 over 1. There, I did the reciprocal, which means I took care of the negative part of the exponent. Now I got to take care of the 2. This is basically a 5 squared, so it's a 25. Boom. Okay. Notice you can go in either order. If you wanted to, you could square it first. That takes care of the 2, but you've still got a negative in your exponent, which means you still got a negative 1, which means flip it over and you get 25. Okay, so that's the nice news, is it doesn't even matter which order you apply the operations. Okay, what do you want to do with this one? Negative exponent. It means the negative means reciprocal. The 3 means cube. Doesn't matter which one you do first, as long as you do both. Now, maybe I'll do this one in 2 ways also, because I see students do it in 2 ways, so if I don't know which way you're going to do it, means I'll show you both ways. One way you might do it is you might say, well, let me get this this flipping over with, which means I took care of the negative part of the exponent, so now it's to the positive through. So I flipped it, right? I reciprocaled the fraction, and now I'm going to cube that thing. So 3 times 3 times 3 is a 27 on top. 2 times 2 times 2 is an 8 on the bottom. And you're looking at 1 over 27/8, which means 1 divided by 27/8, which is 1 times the reciprocal of that, or 8/27. And so in the end, you're getting 8/27. That's supposed to be your answer, 8 over 27. That is one approach you can take. The other approach you can take is you can take my approach. My approach is, hey, negative exponents just means it's unhappy. It wants to move to the top. Well, if you take this whole thing and move it to the top, it's now a positive 3 on the top. And you could say over 1. But who cares about the over 1, right? It's basically just 2 times 2 times 2 is 8. 3 times 2 times 8, boom, you got it. See, wasn't that quicker? That was quicker. So that's the alternative explanation. And like I say, you're going to see me mostly do it this way. I like to just move things over the fraction bar. Seems to save me a lot of energy. energy. All right, what's going on with this one? Back to purple. Negative 5 to the minus 2. Oh, I think you should be able to do that. It's a two-part exponent. I'm going to square, but I'm also going to flip. And again, the exponent is not on this. The negative is just there. Just carry it along for the ride. It's a negative, take a deep breath, 5 to the minus 2. Well, 5 to the minus 2 means square it, 25, but also flip it, 1 over 25. And again, the negative goes on later. Okay, this is not the same as this. This would be different. This would be different. But without those parentheses there, I am not squaring the negative. I am just squaring the 5, squaring and flipping the 5. Okay, back to green. So after you do a bunch of these, you start to pick up on the pattern, right? So I'm putting these out there because these are all problems that I've seen people kind of go, hesitate on or mess up or whatever. You don't want to mess up. You want to get it right. So 2x to the minus 2. The goal here is to, we don't like negative exponents in our final answers. It's kind of like reducing fractions. You want to reduce your fractions, but you also want to make your exponents positive. Usually, I guess not always, but usually you want to make your exponents positive. So I want this to be a positive exponent. So all I got to do is, basically, I don't know what x is. I can't really square it, but I can move it. So it's saying, hey, move me over the fraction bar. So at the moment, you can think of this as over 1, but the x to the minus 2 is going to drop to the bottom like this. And again, the exponent is on x. It is not on the 2, right? It is just on the x. So the 2 stays where it is. The x squared ends up on the bottom. With this one, it is indeed the case that the entire thing is moving to the bottom and being squared, right? So all I took care of there was just the negative part of the exponent. The negative part of the exponent says reciprocal, or if you want, move me over the fraction bar. It moves downstairs, basically. But it's the whole parentheses. The exponent is on the entire parentheses, which means now I'm squaring the whole darn parentheses. I'm taking a negative 2x times a negative 2x, and I'm getting a positive 4x squared. 1 over 4x squared. Oh, you should definitely try this one yourself. Ready? Okay, so first I'm going to do the old move me. I gotta move. So it's on the parentheses. The exponent is on the parentheses. The entire parentheses needs to be cubed and flipped, or cubed and moved might be another way. So I moved it first. I moved it to the denominator. Okay, so now the exponent's positive. And now I have to make 3 copies of a negative 2x, which means I have to do this times this times this. So you get 1 over negative times negative is positive times negative again is negative. 2 times 2 times 2 is 8. X times x times x is x cubed. And please do me this favor, on pain of losing points, I should say, but never leave a negative in your denominator. It's hideous. It's gross. You'll never see that in any textbook. Nothing. You'll never, ever see that. You can just bring the negative out front like this as a multiplier, right? Because a positive divided by a negative is a negative, right? So you can just put the negative right in front. Just put the negative right in front. There, that looks good. Okay, so we're going to end with some combination moves. So what's a combination move? It means I'm applying more than one law of exponent here, just to simplify this mess. So I got this x cubed, x squared, y cubed, but it's being squared, and I got this stuff, and it's being cubed. Okay, I want to apply and whittle this all down. Whittle it down. So first I'm going to apply these outside exponents, the 2 and the 3. I suppose I could literally make 2 copies of this, x squared y cubed times x squared y cubed. I could do that, and then you'll notice that I'm going to have to add my exponents. X to the 2 times x to the 2 is you add, and y to the 3 times y to the 3, you add your exponents, right? Usually I skip this part in the middle. I don't do it that way. I just remember there's a rule that says I can multiply my exponents. So x to the 2 times 2 is 4. Y to the 3 times 2 is 6. And then this is all a multiplication, so I can just keep going here. Now, since this is multiplication, I'm making 3xy squared, 3 copies of that, right? You can actually kind of think as the 3 is on this, this, and this. Now remember, that doesn't work if you do something like this. Okay, you cannot simply do it if there's a big old adding or subtracting in the middle. That does not work. Okay, so just be alert to that. Adding and subtracting usually messes up whatever it is you're trying to do. Is a general observation of life. But in this case, I can sort of go 3 cubed. Well, what's that? That's a 27. I suppose I'll put a times there. X is to the cubed, y to the, and again, multiply your 2 times 3 to get a 6. So after we do the multiply exponents rule, come on you, they put something way too close to the eraser there. Anyway, once you've done the multiply exponents rule, now comes the add your exponents rule. So I've got this whole big bunch of stuff all multiplied together, and I can simplify that. First of all, let's just bring the 27 out front. Let's do the x's next. It's nice to go in alphabetical order. I've got a 4 and I got a 3, so that adds up to a 7. And then on the y's, I got a 6, I got a 6, so that adds up to a 12. So 27, x to the 7, y to the 12th. Cool, so I only basically had to use 2 laws of exponents, the old multiply law and the old add law. What's this next one? Oh, now we're going to use the multiply law, the add law, and a bunch of, like, what does a negative exponent mean law, so to speak. So, now you can do this, you could take various paths on this one. I mean, I do want to square things and everything, and I do want to cube this stuff. I do want to apply my sort of outside exponents, is what I call them, first, but they're negative. So how do you want to deal with the negative is the question. And at first, I ignore that. At first, and this is just my approach, you can take a slightly different approach. As long as you take legal steps and you get to the same answer in the end, everybody's good. It's all cool. But here's how I do, because I like to be careful, because I'm very bad at making mistakes when I try to do too much in my head. So anyway, I have -2 raised to the -2 power, and I have x raised to the -2 power. That's how I'm interpreting this thing. It's extremely important that you put those parentheses there. Why? Because if you wrote this, remember, these mean different things, right? Here, the -2 is on the 2. It's not on the negative in front. Whereas here, the -2 is on the whole thing, because the whole thing's in parentheses, right? So make sure you're clear about that. Since the negative was in parentheses with the 2, I really should keep it in parentheses and put the -2 exponent on it like that. Okay, let's clear up this mess. What a mess. What a mess. So I guess the important part here is I did want to flag this part, I guess. Make sure you have those parentheses. Moving right along, now we're going to play with the -3 here. Here's a -3. This is a -3 being raised to the -3 power, again with the parentheses. Maybe I'll highlight that again. I have x to the multiply 2 times -3, you get -6. I have y to the multiply -1 times -3, you get +3. Okay, so that's what I like to do first. I like to simply multiply my exponents. I'll use, positive times positive is positive, negative times negative. I'll use all my usual rules, but I just multiply my exponents. Then I like to take care of all my negative exponents, which means if you're negative, that's because you want to move. You're negative, that's because you want to move. You're negative too, that's because you want to move. You're negative, that's because you want to move. Y has a positive exponent. So happy where it is. So now all my exponents are positive. And now that all my exponents are positive, I can rock and roll. So -2, when you square it, it becomes a +4. Let's combine x squared and x to the 6th. Add your exponents. It's x to the 8th. And now this -3, when you raise a negative to an odd power, it comes out negative, right? And then 3 times 3 times 3 is 27. So notice what we've got here. First of all, we've got a negative denominator. That's going to make the whole fraction negative. We've got a y cubed on top. Now, I took the negative to the front, so I don't have to worry about that anymore. But 4 times 27 is going to be a 108. and then we've got an x to the 8th power. And there's our prettier version of this. That looks much nicer. Yes, it does. I think I have one more example. Is that right? Yeah, one's enough. One's enough. If you can handle this one, you can handle anything. So I'm actually, the best way to learn something actually is to try it yourself. You've been watching me do it, and you're like, okay, I think I got this. I think I got this, right? But you have to try it and just see, is there any point where you get stuck? When you get stuck and then unstuck, that's where you're burning in your memory. Okay, so that's what you want to aim for here. All right, try this. Pause. Come back. Okay, so the first thing, using my method, I'm just going to first apply all my exponents. So this negative, looking up here now, this negative 3 has an exponent of negative 2 on it. That x there, 2 times negative 2 is negative 4. And then this y here, negative 1 times negative 2 is positive 2. Okay, that takes care of that one. On the bottom, I've got the negative 2 being squared. Let's make that look like a real square. Huh? What do you say? Negative 2 is being squared. This x to the negative 1 times 2, so I multiply the negative 1 times 2, I get a negative 2 there. X to the negative 2. What if I get, where am I? I'm here. Y to the, I'll multiply the 3 times the 2, I got a 6. Okay, cool. So far, so good. Now what have I got? Oh, here's a point worth making. Let's see if you had any trouble dealing with this negative here. For me, the easiest way to deal with a negative on this x to the minus 2 thing is to actually separate it out and think of it separately as a, what are you doing here? As a negative 1. Think of this as a negative 1 x to the minus 2. So the negative 1 is raised to the negative 1 power. And then separately I do x to the, and when you multiply the minus 2 times the minus 1, you get a positive 2. There. So that's all I did was multiply exponents on that thing. Next, I'm going to make all my exponents positive. So I'm looking at this and I'm saying, oh, you're a negative exponent. You want to move downstairs. So negative 3 squared, you're done. Maybe I'll just kind of, as I go, I can just color them. So x to the minus 4, that's going to become x to the 4 on the bottom. Y squared, very happy. Stay where it is. Okay, negative 2 squared, very happy. Come on, you stay where it is. What else we got here? We got x to the minus 2. Oh, unhappy. Move up. Okay, y to the 6th. Happy, positive exponent. I'm so happy. I'm going to stay where I am. Negative exponent. Oh, that needs to move up to the top. Just a negative 1 to the 1. And then finally, this x squared, it's a positive exponent. It's happy. It stays where it is. So now what I can do is I can start, adding exponents. So on the top, what have I got? First of all, I've got a negative 1 to the 1, which is just negative 1. And then I've got an x squared, I've got a y squared. There's really not much to do up there, really. On the bottom here, I got to get used to these pencils. On the bottom here, the negative 3 squared will become a positive 9. Looking at the x's, the 4 and the 2 adds up to x to the 6th. Okay, this negative 2 squared thing here is going to become a positive 4. And then y to the 6th doesn't combine with anything else. So there's all my pieces. So notice that I've got a negative answer. Just put it out front. Now what? Well, I've got x squared up here and x to the 6th down here. I like to just think in terms of canceling. I suppose the law, so to speak, is to subtract the exponents, but why bother? You can just kind of subtract, cancel. So I've got basically the x squared cancels into the x to the 6th, leaving x to the 4th on the bottom. That's a 4. Actually, same deal with the y squared and the y to the 6th. I can cancel y squared into the y to the 6th, and I'm left with y to the 4th as well. Meanwhile, I've got 9 times 4 is a 36 on the bottom. And what's on top? Well, basically 1. So here we go. So if you got that, you should pat yourself on the back and say, I am so ready for the homework. So ready. Negative exponents are my thing, man. That's what you'd say. And if not, well, you know, it comes with practice.